This is Module 20, areas of trapezoids, rhombuses, and kites. If you remember from a previous module, we had to define what a trapezoid was, and that's one pair of sides is opposite sides is parallel. So you have to also kind of recall what the different parts are. We had two bases, one base here, and then we also had a height. We didn't really define the height too much and use it. In this case, we are going to be using it, and again, a height is just the perpendicular segment. So the height of the trapezoid has to be the perpendicular segment, or the perpendicular distance between its two bases, just like in parallelograms. So, area of a trapezoid. The area of a trapezoid is 1/2 the product of the height and the sum of the lengths of its bases. So this is what you actually need to commit to memory or write down in your notes. It's 1/2 your base 1 plus your base 2, whatever those numbers are, or if they're algebraic, times the height, or the actual two-dimensional height that you see. And again, referring to these as little h, little b as well, because again, when we get to 3 dimensions, you're going to have big H's and big B's as well. Alright, so here's your example. So we have the free throw lane on an international basketball court is shaped like a trapezoid. Find the area of the free throw lane. So we have our formula here. So all you need to do is just plug in the numbers that you know. So plug in the numbers. We have our B1 is here. We have our B2 is here. We have our height is here. Plug it in and calculate it. So here's the actual worked out solution. You take 1/2, the height of the trapezoid is 5.8, and times that by the two bases added together here, so we have 3.6 and the 6, and when you calculate it out, it should give you 27.84, and we want the units, which is square meters. Next type of figures that you're going to be finding areas for are your kites and your rhombuses. We're going to do rhombus first. So the area of a rhombus is 1/2 the product of the lengths of its diagonals. And the reason we do rhombuses and kites together is because that's exactly what the area of a kite is. You do 1/2 the lengths of its diagonals, the product of its diagonals. And remember, a diagonal is drawn from one vertex to a non-adjacent vertex, so the opposite vertex. So one vertex to the opposite vertex. It has nothing to do with sides, it has all to do with the diagonals. So here we go. We have find the area of a rhombus, and from previous units, since the diagonals intersect, they will bisect each other. So if we know this is 12 millimeters, that means this has to be 12 millimeters as well. If this is 9 millimeters up here, that means this has to be 9 millimeters down here as well. So once we add the two, to find the total lengths of both the diagonals, all you do is just use the product of the lengths of the diagonals and times it by 1/2. So here's what we did. 1/2 times diagonal 1 times diagonal 2. We substitute it in, multiply it, simplify it, and we get 216. But again, do not forget your units. So your units in this case is square millimeters. Okay, for a kite, one diagonal of a kite is twice as long, or 2 times as long as the other diagonal. The area of the kite is 56.25 square inches. What are the lengths of the diagonals? So we can recall that your area of your kite is 1/2 diagonal 1 times diagonal 2. If we know one of the diagonals, if we know one of the diagonals is twice as long as the other, I can call this one x. That means this one has to be twice that value of x. So when we actually plug this in and use algebra, we know what the area is. We also know what the two diagonals are in terms of x. So that means we are going to be able to actually solve for the unknown. We have 56.25 is equal to 1/2 diagonal 1, which is 2x, diagonal 2, which is x. The 2's cancel out. Algebraically, you get 56.25 equals x times x, same base. You add the exponents, so you get x squared. Take the square root of both sides. Technically, you have plus or minus. Don't forget that when you get into higher level math classes. The square root of this, so you get 7.5, is diagonal 1. So this would be 7.5. And this guy here would be twice that, which would be 15. And in terms of units, we have square inches, so that means that this guy here is going to be inches and inches. And that's it. Okay, so we have the next one. It says find the area of the figure. We have to figure out what type of figure it is. Just basically looking at it, you could probably see it's a trapezoid, but why is it a trapezoid is because these two angles are right angles. That makes these parallel because the two interior angles are supplementary. So if we know that it's a trapezoid, we do 1/2 base 1, which is 6, plus base 2, which is 8, times it by the height, which is 4. So when you do this, algebraic or your arithmetic, it doesn't matter exactly how you do it. I'm going to do 14 because this evaluates to 14 times 2 gives you 28. And again, don't forget your units, feet squared. Okay, again, find the area of the figure. So this guy here, it says this diagonal is 14 based off here. So again, you're just going to do 1/2 diagonal 1, which is 6, times diagonal 2, which is 14. Get 3 here. 3 times 14 gives you 42. Again, do not forget your units. 42 inches squared. Okay, identify the figure. Now we have another area. This is a rhombus again, but we have labeling here. So if we know this is 30, that means this has to be 30. We know this is 40 based off of this labeling. That means this is 40. And again, 1/2, diagonal 1, which would be 60, and diagonal 2, which would be 80. It doesn't matter what you call diagonal 1 or diagonal 2, just as long as you multiply the two diagonals and take half of it. So half of 60 gives you 30. Multiply these out, you get 30 times 80, which gives you 2,400 meters squared.